Well, hey, Math 8, and good morning. Right now, it may not be when you're watching this, but right now for me, it is Friday morning, 8:58 a.m. I'm guessing probably more than half of you are not even awake at this point yet, but oh well. You'll still get to see this content. So, welcome. This is my first midweek feedback video here for Math 8. And yeah, it's right now snowing outside, which is also crazy, but I'm not going to talk about that because we're going to pretend like that's not happening. So, anyways, welcome to the midweek feedback. I just want to really quickly, and I'm going to go fast because I know you guys don't want to watch a big long video. I'm going to roll through so far the three hardest questions on Wednesday's Math 8 assignment. And then also, although many of you have not done it yet, the Friday assignment, the two hardest questions, at least so far, for those who have completed it according to the stats. So let's jump right in. So Wednesday's homework, we've got 4, 9, and 11 are the question numbers here. And so let's talk a little bit about these this sampling and the biased, unbiased stuff going on. So question 4 says to determine the representatives to the recess activities meeting. Two students are selected at random from each homeroom. So first of all, notice they are selected at random here. So the fact that they're at random means that it's unbiased here. So we're unbiased here. We know it's a pretty good way to do it is random sampling. It's a pretty trustworthy route here. But notice what they say here. It says from each homeroom because there are three different types of random samples. So we got to figure out, well, which one is it? So the fact that we've taken two students from each homeroom means that what we're looking for here would be stratified random. Now let's break that down really quickly here. So stratified comes from the word strata, and the word strata you can just think of as group or groups. Okay, if I break things into strata, it means I'm assigning them into groups. Kind of like at school, our strata would be the different classes, right? So maybe you're in Mrs. Joel's 4th hour, or maybe you're in Mrs. Lotson-Heiser's 7th hour, or whatever the case is. So strata would be you're breaking them into groups. So notice here, we're not just picking two students at random, but two students at random from each homeroom. So from each group or from each strata. Therefore, we would call this stratified random. Okay, let's look at another one here. This is question number 9. Two teachers, notice, from each school. I'm starting to see some similar language. I don't know about you. So two teachers from each school. So it's like each school in the district here, it says, so in the district. But each school in the district here would be a different group, right? So TJ would be a group of teachers. The high school would have a group of teachers, so you'd have all these different groups, and you're going to pick two teachers are chosen at random, once again, from each school. So once again, I would say this is unbiased. We're selecting them at random. And then what kind of sampling is it? We know it's random of some kind, but once again, there's the three types. There's simple random, stratified random, and systematic random. But once again, because it's kind of a group, each school, we're going to once again say stratified random. So I'm guessing the reason why a lot of people are missing these questions is because, once again, we don't completely understand what makes for a stratified random, and it's because you have different groups that you're picking some at random from a certain amount from each group. So last one, number 11. This one's actually a little different, though. So to determine how often people eat out, every 10th person entering a Chinese restaurant is surveyed. Now, the every 10th person, I can see where this is tripping people up. This would be a pretty good example of what we call systematic random, right? We have a system. We have a way to go about it. We're going to say, hey, every 10th person that comes into the restaurant, single them out. We're going to give them a survey. We're going to see how often they eat out, right? So at first glance, it seems unbiased and it seems random, and it would be what we call a systematic random. We've got a system where every 10th person we're going to survey. But the problem here is that we're wanting to figure out how often people eat out, and we're only going to go to one restaurant, and it's going to be a Chinese restaurant, and we don't know much about the restaurant. Maybe it's like a fancy restaurant that you only go to for Easter or Christmas brunch or something that you hardly ever go to. Or maybe it's something where people love it and they go there every night, and it's, once again, so we don't know. It doesn't necessarily represent maybe all of the restaurants around town. And so it's actually not unbiased. This would actually be an example of one that's biased. So it is a little tricky. It's because there's only one restaurant that's used here to figure out how often people eat out. And so, and because it's just one restaurant, it's what we would call the convenience, because there's basically two types of bias sampling. there's the convenience, and then there's a voluntary response. And so every 10th person isn't volunteering, right? We're picking them. So it's not voluntary response, but we would say it's convenience, because it's convenient just to go to one restaurant and then just, survey every 10th person that comes in. All right, that's the first one. Here's Friday's homework, the 2 toughest questions I've seen so far. And so I'll try and go through these quickly here. So for these, we're setting up proportions to figure out kind of to make a prediction of the overall group given our little sample. So we'll have like our little fraction for our sample equals, and when they're going to try and extend that to the whole big group and make predictions. So here we got Student Council of Del Mac Academy said that they will request the school to change the passing time between class periods from 4 minutes to 5 minutes if at least 800 students approve it. Okay, the Academy has 1,400 students. You interviewed a random sample of 150 students and found that 85 of them approve it. Do you think enough students will approve the decision? Okay, so we know in our sample, right, we had 85 out of 150 that were in favor. They would approve it, okay? So that's our first fraction, right? We know every 85 per 150 would approve it. We're going to see, okay, is that going to be enough here for the overall student body? So the overall student body would be on the bottom over here, it'd be 1,400. And then a lot of these problems, they wouldn't give you anything for this top number. Now here they gave us 800, but we need to have a variable somewhere. So what we're going to do is we're going to put X here. We're going to figure out, does X, is that going to be enough to hit the 800 or not? Okay, so this one is kind of a little bit harder because we got to first figure out X and then actually compare it and say, okay, is it 800? Is it not 800? Are they going to approve it or they're not going to approve it? So let's go ahead. From there, we're going to do cross multiplying. So here's where I'm going to grab my calculator. Okay, we would start with 150x. I'll go ahead and start with that side. Okay, and that's going to be equal to, then on the other side, we're going to multiply together there, 85 times 1,400. Okay, I get a pretty big number here, 119,000. Okay, and then at this point, it's just an equation, right? To figure out what X is, we'd have to do the opposite of multiplying. We'd have to divide both sides by 150. That'll get X here by itself. We may not get an even number, and that's okay. We get, 793 and 1/3 or 0.3 repeating, that kind of thing. But the question once again is, did we hit the 800 that we think we're going to need to approve this decision? In this case, we just fell short just by about 7 or so, but we fell short. So do you think the students will approve the decision? In our case, we have to say most likely not. So we're going to say no. And we would say that it's because we did not hit 800. So that's actually one of the multiple choice options there you can select as the answer. All right, last one. I'm not going to go all the way through question 10, but I at least want to set it up because I know this one will be tricky as well. So the chart shows the preference of a sampling of 100 voters in the student council election. So a different problem here. We've got a student council election. At this point, we've got 5 candidates, right? Everett, Franks, Gogin, something like that, Manley, and Rogers. And so 1,500 students voted in the election. So that's a number that we'll need, right? 1,500. Okay. And they say if Franks drops out and his votes are divided among the remaining 4 candidates, then what is a reasonable prediction for the number of votes received by Everett? So what we're saying here is that Franks is dropping out. Okay. Now Franks, though, when we took our sample of these 100, he took 32 of them. He took about 1/3 of the vote here, which it's crazy that he's dropping out, right? Because right now he looks like he was going to win. But anyway, so he's dropping out for whatever reason. And his votes are divided evenly, right, among the remaining 4 candidates. So if we have 32, we divide 32 by 4, that gives 8. So basically each of these are going to get an upgrade by 8 because we're getting rid of those 32 right there. Okay, so that means Everett actually doesn't have 27. He's got 27 plus 8. So he's actually got 35 is the number we're going to use. Okay, so we're saying approximately, this is why it says it's a reasonable prediction, right? Not going to be exact, but it's a way to try and predict what's going to happen here. So 35, we would say over 100 for our sample is equal to, and then we're going to figure out, all right, well, when we're talking about the whole vote, which is the 1,500 students, we're going to try and figure out, okay, how many is he going to then get for that? So at this point, you cross multiply, solve it, get your answer, plug it in. And that's going to be it here for this midweek feedback. Let me know if this is helpful. I hope to do one of these every week. We'll see if it's helpful for you guys. So otherwise, I hope you guys have a great weekend. And yeah, we'll see you next week.